Hi guys, welcome back. In continuation of the previous video, we'll try to have a look at physical layer of the Node B logs today. So physical layer B is bit complex and also it has so many different details to understand in order to analyze and understand in a better way. Okay, so I'm just trying to give from the physical layer perspective, maybe a short introduction related to the physical layer LTE. Example, we have different channels: PDSCH, PDCCH, PUSCH, PUCCH, right, and PRACH and also PMCH. Later we have transport block size and different parameters basically, and PRBs and also DCA formats, right. So these are all different topics that we can see and try to understand: TDD, FDD mode, and also frequency mode of operation, ARFCN, right. So all the things are basically a part of a physical layer discussion. Maybe for more details before jumping into this particular log, please try to understand from the physical layer perspective in the 4G physical layer design course. You can check it out in that particular video. You'll come to know about this in much more in detail. Okay, so now let's try to see quickly jump into this particular physical layer log analysis. Again, this is just an L3 call, and also once the L3 call is complete, UV is going to the idle mode, and later the paging is triggered. Okay, and for that it is again initiating RS connection where it can get another RNTI, which is 0x47 in this particular log. Okay, and then it will try to connect to the base station in order to fulfill the request. So this is the scenario that we are actually going to analyze with the help of physical layer. So we'll try to have a look at some of the physical layer before jumping into the actual scenario. Okay, so as usual, I'm just trying to give the mapping related to the timing, what actually the RRC related to the OTA messages, how the physical layer is actually behaving. Is there any RF considerations that we have to see, right? So those things we'll try to see in this particular video. Okay, so to start with, you can see where I'm just jumping into the file for searching and getting the results. You can see, yeah, so these are all the results that I got it. I'm taking in a separate page to understand better, right? So these are the physical layer logs we are trying to analyze. Okay, now you can see this is band pass filter. This is like just RF configurations basically. Component carrier worker, which means one cell, which is 50 PRBs, which means 10 megahertz signal, right? So on TX and RX thread is actually created for the physical layer, right? PRACH, preamble, max offset, PDCCH, PDSH, which means this is for the downlink. Or if you have a doubt, we can try to map it with the RRC. Okay, so I am going into the RRC logs to get the timestamp to understand what is currently happening. Let's say RRC here, this is 242.488, right? So 242.488 is here, right? So nothing is actually happening from the file layer perspective. RF is there, RF is configured here, right? So there are no RRC messages right now, only this system information 8 SI messages basically. Okay, and then here the component worker threads are there, physical layer is there, right? So there is no RRC related messages. This is just setting the timer related to the recovery if there is any radio link failure, right? And physical layer, right? So this is related to the initial message, right? The PRACH is there here, correct? Physical layer. So here you can see some of the physical layer parameters here. So the same things that we can see in the file layer logs. So I'm just trying to search example. Here you can see RRC connection request. So for the RRC connection request, so this is the timestamp I'm taking currently. Okay, so I'll just put the timestamps here. This is one timestamp, right? Another timestamp is RRC connection setup, right? RSC connection setup is there. So here and there with respect to the timestamps, so all the physical layer logs also you can able to see RNTI, F value, CC value, aggregation level, resource indicator value, PID, process ID, ARC process ID, modulation and coding scheme, right? Transmission power control, new data indicator, correct? Component carrier, RNTA, right? All these things that you can able to see. So now for this RSC connection setup, you can see physical layer 0, right? So in order to fulfill this connection setup, so this is the first physical layer 901, you can see 901, correct? Now for the RNTA 46. So in the previous discussions also we have seen the RNTA allocated is 46. So number of PRBs are 3, number of resource element 450, transport block size 32, modulation, right? Redundancy version, correct? All these details that you can see from the physical layer point of view. So here another one, PUCCH, different channels, but we have to map the timestamp. We have to map the timestamp. Example, yeah, just now we have seen 901. 901 is related to what? It is related to RSC connection request, sorry, RSC connection setup. Now here it is RSC connection setup complete. For the RSC connection setup complete, okay, this is uplink. RSC connection setup complete is uplink, which means in order to send this, we are preparing here all PUCCH, PUSH. So this will carry the RSC connection setup complete because UV has to send, and as a base station we have to allocate the resources, then only it can able to send, right? So for this RNTA, we are giving PUSH resources, and this is the number of resource elements, this is a size that you have to actually send, and CRC, okay, right? So this is the main thing that you can see and analyze. So the same thing you can see in the log, because we have taken the same logs here, right? And it will continue, this will keep on allocating the resources, this is a scheduler basically, and the combination of MAC and physical layer. So in order to understand better again from the MAC perspective, we will try to dig deep detail in the upcoming video, which is in the MAC discussion. We will try to see how these are actually mapped, how this is actually scheduled, because since this is a physical layer log, right, we are trying to understand only the physical layer channels, wherever you see all the channels. So this is component carrier, this is RNTA, right? DMRS correlation, what is the signal to noise ratio, right? CQI, all these things that we can try to see and analyze only from the file layer perspective, correct? You can see majority of the things are there here, majority of the things are there. We can try to correlate and try to get the timestamps for that. So there are some different values out there. So in order to understand, I think again I have just mentioned PUCCH. So all, what is this channel, what is this channel, what is PDSH, PDCH, these are all like fundamentals related to the physical layers in the LTE discussion. So please go and check it out if you are not familiar with this terminology in the physical layer discussion. Okay, so range of discussions that we can see, range of layers also will try to analyze and understand things in detail. Resource block group, right? Process ID, or process ID. So these are all part of DCA formats. By the way, DCA is basically downlink control information. It is applicable for both uplink and downlink. If it is downlink, we are actually scheduling PDSH, which is physical downlink shared channel, and ULDCA means it is PUCCH, which is PUSCH. Okay, so PUCCH is for the UCA carrying information, but the scheduling of the PUSH is with the help of ULDCA, which is uplink downlink control. Uplink DCA. Okay, so those things are actually coming in the downlink itself in the PDCCH, so that you can able to interpret uplink DCA or downlink DCA. If it is uplink DCA, it is related to PUSH, where UV in the next stage of the transmission opportunity or in that particular scheduling interval, UV can able to send that particular data in the uplink. So if it is PUCCH, then UV is actually carrying the CQI, PMI, RI and other ranking index and other SR, right? So these are all the different information that UV is actually carrying in the PUCCH. So those things and all actually I have discussed more in detail in the physical layer discussion. So I think you can able to check the details in that physical layer course. Okay, now another one is PHISH, which is acknowledgement. This is a downlink. So for this particular RNTI, what is a HARC, which is positive or negative, right? So that we will come to know. If it is 1, it is positive, which means positive acknowledgement. So there is no need of retransmission required in the next transmission opportunity. That is the main indication in this particular case. So here also you won't be coming to know related to whether it is L3 call, because this is purely at the bits and byte level processing and allocation of the resources, frequency, time, power, modulation scheme and other aspects, and checking the BLER and SANR and SNR related aspects, so that whether the quality of the signal is good, whether the cell signals are good, cell conditions are good, right? All those things that we can see in this particular physical layer aspects, whether we have a single layer, multiple layers related to MIMO configurations, what is the transmission mode, what is the ranking index, and accordingly we can have the DRV aspects. Okay, so there are so many different calculations are also there. Okay, so you can check it out in the physical layer video. Thank you. Let's stop here. I think we can continue in the next layer, which is MAC. That is going to be very interesting. Please don't miss out. Thank you and see you again.